Welcome to Erin Online Academy. We are still on chemical formula, and this is lesson 4 on chemical formula. Our focus for this particular lesson will be on calculating empirical formula and molecular formula. In the previous lesson, lesson 3 of chemical formula, we actually look at the definition of empirical and molecular formula, and we also differentiate between the two types of formula, giving examples of specific compounds and how the empirical formula varies from the molecular formula. But in this particular lesson, our focus will be on calculating empirical formula, giving certain information about the specific compound, and of course calculating the molecular formula when you have additional information given, having derived or having determined the empirical formula. So let's look at an example. Okay, but in case you've forgotten what empirical formula is, a molecular formula, or the difference between the two types of formula, refer to video on lesson 3 so that you can be able to do a quick job of recalling. Okay, now looking at this example, a sample of a compound contains 4 grams of hydrogen and 64 grams of oxygen only. So only simply means that this particular compound contains only hydrogen and oxygen. Only hydrogen and oxygen. Those are the two elements that are constituent of this particular compound. If its molecular mass is 34 grams, determine its empirical formula. And the second question says its molecular formula. So how do we go about calculating empirical formula? Okay, now to calculate empirical formula for this question, the first thing you have to do for any given question that you have to determine the constituent atoms. In this case, we have carbon and we have hydrogen and oxygen. Hydrogen and oxygen. So if you go back to the question, you need to also find out the masses of the elements given. The masses of the element given. So in this case, we are given 4 grams of hydrogen and 64 grams of oxygen. So you have to find the masses given for each of these. So the mass for hydrogen is 4 grams, while that of oxygen is 64. So you have 64 grams of oxygen given. So the next thing, in order to calculate the empirical formula, and you have to listen carefully, is to divide the respective masses by the relative atomic mass of each of the elements. So the next step will be your mass divided by the relative atomic mass of the individual element. Okay, now your relative atomic mass, okay, in your periodic table, refer to the periodic table. Okay, periodic table of elements. You have 2 numbers attached to a particular element. For hydrogen, in the periodic table, you have 1 and 1. Okay, for oxygen, in the periodic table, you have 16. Okay, you have 16 and 8. Okay, in this case, 1 represents your atomic, relative atomic mass. The bigger of the 2 number is the relative atomic mass. Okay, while this is your proton number or atomic number. Okay, proton number or atomic number. The same thing for hydrogen. Okay, you have the relative atomic mass, usually the number attached at the top, but to be safer, the bigger of the two number. But for hydrogen, its relative atomic mass is 1, while its proton number or atomic number is also 1. Okay, so you need to be familiar with your periodic table. Looking at the periodic table of elements, you have two numbers attached to, okay, two numbers attached to your element. Okay, you have a number at the top, usually a number at the top attached, then you have another number, attached at the bottom. Okay, you have number at the top and at the bottom. Okay, for oxygen, usually you have your 16, okay, and of course you have your 8, written here. So go refer to the periodic table. This is your periodic table of elements. Okay, here I have oxygen. Okay, you can see 8 and what, 16, 8 and 16, and of course we have hydrogen here. We have 1 for the atomic number. So the atomic number for hydrogen, it's 1, but its atomic mass, relative atomic mass, is 1, and that of oxygen, atomic number is 8, and the relative atomic mass is 16. So let's go back to solve the problem. So you have 4 divided by relative atomic mass, which is 1, and 64 divided by the relative atomic mass of what? Of 16. Okay, so the next thing will be to find your answer, which will give you the ratio in which the atoms exist in the compound. Okay, so 4 divided by 1 will definitely give 4. 4 divided by 1 will give 4. Okay, and 64 divided by 16 will give 4. 64 divided by 16 will give 4. So the ratio in which these atoms exist is ratio 4 to 4. Ratio 4 to 4. So the simplest ratio of these elements, the simplest ratio, okay, the simplest ratio is ratio 1 to 1. Okay, so your 4 divided by 4 will give you 1. Also 4 divided by 4. I'm doing this so that we can get the simplest ratio. So because the empirical formula shows the simplest ratio in which each atom in a particular compound exists. So hydrogen to oxygen here exists in ratio 1 to 1. So your empirical formula is H1 and O1. H1 and O1. But because the numbers, the subscripts here are the same, you have H here, and H1 and O1, because they are the same. So to get the empirical formula, it's just H and O. So this gives us our empirical formula for this particular compound. Now the second question says find its molecular formula. So what other information do we need to find the molecular formula of a compound having derived its empirical formula? So looking at the question, we were given 34 gram as the molecular formula of this particular compound. Okay, so of course in calculating as the molecular mass, we're given 34 gram as the molecular mass. Of course, to calculate the molecular mass of a particular compound, calculating the molecular mass of a particular compounds requires that you add up all the relative atomic masses of the constituent element. Okay, so this particular compound, its empirical formula is HO. Okay, but assuming we know the actual number of each constituent element in this particular molecule, then we'll be able to represent the molecular formula in the proper way. Okay, so what I'm saying is this: in order to be able to get 34 grams, which is the molecular mass of this particular compound, then there will be a need to calculate the relative atomic masses of the individual atoms present. Okay, but since this is the empirical formula, we are not so certain that adding the relative atomic mass of hydrogen, which is H, okay, to the relative atomic mass of oxygen will give us 34 grams. Okay, hydrogen is 1 gram, oxygen is 16 grams. So adding the two together will give us 17 grams, which is not equals to 34 grams. So what is the implication of this? This is simply telling us that this empirical formula, okay, needs to be multiplied by a given integer. The empirical formula needs to be multiplied by a given number, okay, such that it could give us the what? The molecular mass. That means, looking at this, since 17 is not equal to 34, that means we have more than one hydrogen in this compound, and we also have more than one oxygen. That's the implication of this. So the question says that the molecular mass of the compound is 34 grams. So how do we find this N? So all we need to do now, we know we need a number to multiply the empirical formula, which we derived earlier, in order to be able to give us 34 grams. Okay, so we'll look at this bracket now. N1 plus 16, okay, will give us 34 grams. Okay, so we have N17, 1 plus 16 will be 17, to give us 34 grams. So we have 17N equals to 34 grams. So let's find N. N therefore will be equals to 34 grams divided by 17, and that should be equals to 2. Okay, N equals to 2. So if N equals to 2, now we have gotten the number we are looking for. So we go back to this empirical formula here. Okay, from that number we can see now that N multiplied by HO will give us a correct molecular formula. So yes, we're almost getting there. So let's arrive at what the molecular formula is. So if I open up this, I'm going to be having Hn, because in a formula you put your number as subscript to be able to show the number of atoms present in a particular compound. So N comes in as subscript, then oxygen comes in as subscript. Okay, so of course we found out that N is equals to 2. We found out that N is equals to 2. So what you do is to substitute in 2, okay, for N. So let's do that. So we have H2O2. Wow, H2O2. Okay, so the molecular formula, our molecular formula is equals to H2O2. So we can see the differences again between the empirical formula and molecular formula. You can see the molecular formula tells you the actual number of each atom present in a compound or molecule, while the empirical formula just tells you the ratio in which what they are present. Okay, I think this is interesting. Let's take one more example. Okay, now looking at this, it says a compound contains carbon, hydrogen, and oxygen. So we have three elements in this particular compound: carbon, hydrogen, and oxygen. X contains 54.4% of carbon by mass. The same thing, the value of hydrogen was given and the value of oxygen was given. The first part of the question says calculate the empirical formula of the compound. So that's what we are going to do first, calculating the empirical formula of the compound. So I believe you remember your steps. The first step is find the constituent element. We have hydrogen, okay, and carbon, hydrogen, and oxygen. So your first step will be your mass. What are the masses that we have there? The first one told us that for carbon we have 54.54. Okay, so let's move on. 54, okay, 0.54, 54.54. And for hydrogen, it says we have 9.09, and of course for oxygen we have 36.37. Okay, 36.37. Okay, so now the next thing to do is you divide the mass by the respective relative atomic mass of the individual atoms given. So let's go ahead to divide. What is the relative atomic mass of carbon? What is the relative atomic mass of carbon? Referring back to the periodic table, your carbon is this in the periodic table. You have 6 as the atomic number and 12 as the what? As the relative atomic mass. Okay, 12 as the relative atomic mass. So let's go ahead to divide. This will be divided by 12. Okay, for hydrogen, same, the relative atomic mass, check your periodic table, it's 1. And for oxygen, the relative atomic mass is 16. So we divide 36.37 by 16. So what is the first ratio that we'll get here? The first thing is you get a ratio of in which the atoms exist, the raw ratio if you like. So here, if you divide 54.54 by 12, use the calculator, that should give us yes, okay, 4.5 here. Now 9.09 divided by 1 gives me 9.09, and 36.37 divided by 16, okay, that gives me 2.27. So the next thing to do here, just look at this ratio. What can we do to get the simplest whole number ratio? The simplest whole number ratio. So the next thing to do now is to divide this raw ratio gotten by the simplest of the number, and the simplest one here is 2.27. in order to be able to get the simplest ratio. Okay, our focus now is to get the simplest ratio. Okay, the simplest ratio. So let's go ahead to divide. So we have 2.27 divided by let me erase that properly. So the 2.27. Okay. Okay. Then the next one is to divide this by 2.27. Okay, and to divide this by 2.27. Okay, so 4.5 over 2.27, that gives me 1.982, and this gives me 4.004. This gives me 1. Okay, so looking at this number, the best that could be done here is to approximate this to 2, and this to 4, and this to 1. Usually you have to be careful with approximation, okay, but looking at this particular number, the best to do to this, to get the nearest whole number ratio, is just to approximate this. Okay, it's safe to approximate like this. So the empirical formula, therefore, okay, empirical formula because to, since we have 2 for carbon, we have C2, okay, H4 and O1. So invariably, how do you write it? Okay, it is C2H4O. C2H4O. That's the empirical formula. Okay, the second part of the question says compound X has a relative molecular mass of 88. Deduce the molecular formula of compound X. So to deduce a molecular formula, okay, just like the previous example we'll look at, so now you should remember that your empirical formula, okay, okay, multiplied by a given integer will give you the molecular, will be equals to the molecular what formula. Okay, and of course, if you have the molecular formula, if you add up, okay, if you add all relative atomic masses, okay, in a formula, in a molecular formula, then it's going to give you the what? The molecular mass. Okay, but luckily we've been given molecular. Okay, so let's calculate empirical formula that we got. We have C2, we got C2H4O. So we don't know what number we need to multiply that. Okay, and we've been given from the question, we're given the molecular mass to be what? 88 for the compound. Okay, now if the molecular mass is 88 for this particular compound, so how do we go about finding the empirical formula? Molecular mass is 88 grams. Okay, so what do we have here? We have carbon is the relative atomic mass of carbon is 12. Check it from your periodic table. Okay, and we have 2 carbons, so I have 2 carbon atoms here, so I need to take this stepwise so that you won't miss out. Okay, plus I have 4 hydrogen, okay, atoms here, 4 hydrogen atoms plus 1 oxygen multiplied by N to give me 88 grams. So carbon is 12. Relative atomic mass of carbon is 12. Okay, that of hydrogen is 1. Carbon is 12. Okay, I hope it's simplified now. Carbon is 12, hydrogen is 1, and oxygen is 16. Since we have only 1 oxygen, there's 16. Okay, N equals to 88 grams. So 2 times 12 gives me 24 plus 4 plus 16. Okay, multiply by n to give us 88 grams. So if you add up all these, what do we get? We're going to get 44. Okay, 44 n equals to 88 grams. So n will be equals to 88 divided by 44, and that equals to 2. Okay, so if n equals to 2, going back to empirical empirical formula here to equals to molecular formula. So if n equals to 2, then let's multiply the empirical formula back, just looking at this. Okay, so we have C2H4O multiplied by n. So therefore it will be C4, because we already have 2 here. C4H8, that is 2 coming in, which is your n, by 4. 2 times 4 gives you 8. Okay, and what? And O2. This is our molecular formula. That's the molecular formula. Pretty simple. Pretty simple. So I hope you've learned from this video. I'll see you in the next lesson. If you like this video, share and subscribe to my YouTube channel. Catch ya. I am your professor, Lanre Oguntoye. Thank you.